Hi, hello, good morning. So today we are going to discuss about the projection of points. So this is a very important topic and you should be very careful to understand what is the projection. So this is nothing but the orthographic projection. So before going to the projections, we have to clearly understand that what is a quadrant system. So in the further slides, you are going to understand what is the quadrant system and what is the projections and what is the projection of points. Right, let us go into the topic. That is, you can see here on the screen projection and a quadrant system. So here vertical, you can see now this mark. Okay, this is the vertical plane. You can see an line, it is vertical, so this is called the vertical plane and it is also called as VP. And here you can see the horizontal plane is this is called as the horizontal plane. So right, and right to the half of this one quadrant is called the first quadrant in this area, and behind this vertical plane and above the horizontal plane, this is called the second quadrant, and the bottom one is third quadrant, and this side is the fourth quadrant. So this is a very clear explanation about the quadrant system. There are four quadrants in a quadrant system. This is one, behind two, below three, and below in front, that is four. So four quadrants are there. So on these four quadrants, it is going to depend that when an object is placed in different quadrants, the view of that projections, that is orthographic projection of that particular object, is going to get in different manner. So here, as per the engineering graphics or engineering drawing, only we will accept first quadrant and the third quadrant. So why the second quadrant and the fourth quadrant is not accepting? Because when the object is placed in the second quadrant or in the fourth quadrant, the view which is going to appear will be overlapping with each other, so that you can only view one of the projections, so that you cannot judge the geometrical shape of the particular object such that the two quadrants, that is second quadrant and the fourth quadrant, is eliminated from the engineering graphics, and only the first quadrant and the third quadrant is selected to orthographic projections. And when the object is placed in the first quadrant, it is called as first angle method of projection, and when the object is placed in the third quadrant, it is called as a third angle method of projection. So now let us go for another slide, that is projection of planes, that is anyone with the representation and its symbols. Right, let us take, this is an object. Okay, this is an object. So when object is placed in the first quadrant, I have already said that this is first quadrant and this is second one is this one is interchanged, and this one is the second quadrant, and this one will be the third quadrant, and this is the fourth quadrant. So please change it, this one. So then next, when you are like sitting here, okay, where I am showing here, you are sitting here. So this is you. Let us take a smiley you. So when you are seeing from this side of this object, the view of this object is going to fall on the vertical plane, So this is called the front view of the object, as you are seeing from your front. So as in the same case, when you are looking off for the object from the top of it, so from like this, so the view of this particular object is going to look on the horizontal plane like this. Okay, so now as you are here, you cannot go on the top of that object. Suppose if an object is small, you can go on the top. Suppose if it is building, then you cannot go over than that of building. So as you are sitting here, by seeing on a horizontal plane, you cannot see. Suppose, let me show you one of the examples. Suppose if like this, suppose a point is there here, you can see the point here. Suppose if I take the same point here on this side, and I'll rotate this one. Can you see the point here what I have marked? No, so it is not possible. So what I have to do is I have to rotate this one in this direction such that you will look at, so that this horizontal plane is going to be rotated in clockwise direction for 90 degrees, so that this object is going to appear below the reference line. This line, what I am showing, this line is called the reference line or the quadrant axis, such that where the vertical axis, vertical plane and the horizontal plane is going to meet, that is called nothing but the axis point. So right, so this is first explanation or first angle method of projection when an object is placed in the first quadrant. So let us see the second one is when an object is placed in the third quadrant. So now let us imagine this is a transparent plane, transparent vertical plane. So now once again you are sitting in the same place, okay, you are observing it. So the view of the object is going to appear on the vertical plane like this, okay. So from this, and once again the same view when you are looking from the top, right, this is going to appear on the horizontal plane. Where this horizontal plane, we cannot view this picture, so that it is going to be rotated in clockwise direction for 90 degrees, such that the top view is going to appear on the right side. Now this is the explanation how the representation and the symbols are going to be written on a paper. So now this shows you the symbol of a representation for the first angle method of projection and third angle method of projection. You can see here, if you go for the previous slide, once again I will go for previous slide. So here this is the front view and this is the top view in the first angle method of projection. So simply you can see this is the front view and this is the top view, and if you can rotate this in the clockwise direction, then it is easily to identify this top view and front view, right? So this is the front view and this is the top view of an object in the first angle method of projection, and this is the representation of the first angle method of projection in your drawing sheets. And next one, coming to the point of third angle method of projection, this is the top view and this is the front view. Why these two views are interchanged? So front view is the first quadrant, the front view is first, and in the third quadrant, the front view, the top view is in the second place. So by this you will be identified in the next further projection of points. So let us go to the projection of points. So there are basically 9 types of projections of points in the space. So what is that space? That space is nothing but the first quadrant, that is in the right angle, and another one is third angle. So that is third 180 to 270 degrees. The first one 0 to 90 degrees and third one is 180 to 270 degrees. So here let us see what are the 9 different conditions that an object or a point can be placed. Okay, the first one is in first quadrant the object is going to placed above the horizontal plane in front of vertical plane, above the horizontal plane and in front of vertical plane. And I will clearly explain you in pictorial form in the next slides what is above horizontal plane and what is about in front of vertical plane, right? So the second condition is, so in the second quadrant above horizontal plane behind vertical plane, and in the third condition, the third quadrant, if an object is placed in the third quadrant below horizontal plane and behind vertical plane, and in the fourth quadrant if an object is placed, it is so called the position below horizontal plane and in front of vertical plane. And the object may be in the plane, that is on the VP above the HP, on the HP behind the VP, on VP below HP, on the HP in front of VP, or on both VP and HP, that is horizontal plane and vertical plane. So how these type of conditions are going to be given, it is easily understood. So just I will explain you these 9 conditions in the previous slides. So I will go back once again. So see here itself the opposite is first. Now this object is there. So now this is the horizontal plane. So if this object is placed in the first quadrant, object is above the horizontal plane and in front of the vertical plane. Suppose let us take the same object here. Let us take this arrow mark. So now this is above the horizontal plane and behind this one, because you are sitting in the same place and you are observing it. That is nothing but this object is behind the vertical plane. And you see the same here object. It is in the third quadrant. You are here. That is nothing but the object is behind the vertical plane and below the horizontal plane. And if you take the same here, the object here, so called here, this the condition is in front of vertical plane and below the horizontal plane. So these are the different conditions that you are going to get. So these are the different conditions. So we'll go for the directly, we'll go for an exercise problem or an example problem, that is the projection of points. So first of all, what is the procedure? So the procedure is, first you have to draw a line that is called the axis. Okay, write it as axis here. Then next, draw a vertical line which crosses and it separates as a quadrant system. Let us take this is the first quadrant and this is the second quadrant, this is the third quadrant and this is the fourth quadrant. So today I will explain you how to draw the orthographic projection of a point which is placed in the first quadrant and as well as in the third quadrant. So now let us see the first one. A point is placed in the first quadrant, means here in this space. So this is the space where I can have a point anywhere else in this area. So simply I am putting a point here. Okay, so this is the first quadrant. This area is first quadrant. Now I'll mark it as A. Okay, so now in the previously you have seen I am sitting here. You are observing in this direction so that the front view appears on the vertical plane, right? So vertical plane. So here the front view is appeared here. So this front view is named as A dash, a small letter. So the naming of the point is given in capital and the front view and the top view is given in the smaller case, lower case. So A dash. And in the same case, the point is here above the horizontal plane and it is in front of vertical plane. When I am seeing from the top, the top view appears on the horizontal plane and it is named as A, that is small a, right? So now it is a simple thing to construct an orthographic projection of point A. So how it is? Let us see. So draw a line. So this is an axis and this is a line. Okay. So where is the front view? So this is the reference point. So you take the reference point as this one. Okay, fine. Where the reference point, how much distance is there? How much height is there from the reference point to A dash? So just simply draw on the same line. This is A dash. Okay. And next, where is B dash? Sorry, A. So A is appeared on the horizontal plane such that when you are sitting here, you cannot view the point A on the horizontal plane, so that it is going to rotate in 90 degrees, right? So it is rotated in 90 degrees such that this point A is going to appear on the vertical plane below the axis. So now name this one as A. And simply just draw a line here, not a line, just it is an imaginary line, and put a point here A and name it as A. So this is the front view and this is the top view. So when an object or when a point is placed in the first quadrant, you can easily identify that front view is appeared above the axis and the top view is appeared below the axis. So now this is the explanation for point A which is placed in the first quadrant. And next let us go for the point, another point placed in the third quadrant. Okay, third quadrant. So let's see. I'm taking point B here. Okay, I'll name it as B, right? So front view, where you are. So now once again you are sitting in the same place and you are observing this point front view will be appeared here. Okay, and name it as what? B dash, because this is. So let us take, this is the point B, which is placed in the third quadrant, right? Then now you are sitting here once again the same place, and this point B is going to appear on the vertical plane below the axis. So here you are going to appear the front view of this point B. This is B dash, and if you look from the top of the object, and the top view is going to appear on this line, that is horizontal axis, name it as B. So now when the horizontal plane, the view on the horizontal plane cannot be viewed such that it is going to rotate in 90 degrees in the clockwise direction, such that this point is going to move from the top, this is going to move. Now when an object is placed in the third quadrant, it is easy that the front view is coming below the axis and the top view is going to above the axis. Now let us draw the orthographic projection of the point B. So now draw a line. So here draw a line perpendicular to the axis, and now front view is here. Just you draw a dotted line, or you can just have a scale and put a point here and just name it as B dash. That is nothing but when to the reference line or a reference axis point, how much distance is there that you are going to put at this particular point. And in the same way you are going to rotate this one here, and you are placed this point on the above the axis reference. So at the same distance from this point to this point, so simply you take this point to this height and you put a mark and name it as B. So this is how you can easily identify when an object is placed in the first quadrant, the front view is above the axis and the top view is below the axis. In the same way, when the point is placed in the third quadrant, the front view is appeared in the below the axis, and this is above the axis. In the previous case we have seen the symbol and representation of the objects. So here that is interchanged. So here you can easily identify, here it is the front view above the axis and here it is below the axis, and the top view is below the axis in case of first angle method of projection, and in the third angle method of projection the top view is above the axis, right? So next time we'll go for the another concept, that it is the same thing. Draw an axis line and a vertical line. When an point is placed in the vertical plane and above the horizontal plane, so this is a condition, in the vertical plane and above the horizontal plane, where now you are sitting in the same place. Here you look here, so your point is going to appear on the same plane at this place only. Just simply you observe a color change will be there, such that this is point A and color is changed here. Now this is represented as A dash, because the point is looked at the same place. And where does the top view appears? You are now right now here, you observe this point, it is on the vertical plane, so S is going to appear at this junction point, that is nothing but the reference axis line. So this is the point and it is named as A, right? So how to draw the projections of this one on the orthographic projections? So first draw a vertical line to the perpendicular to the axis, and as usual in the previous case, simply draw a point here and put it as A dash, and as it is in the intersection of these horizontal plane and vertical plane, just you put a point here and just mark it as A. So now this is the orthographic projection of point A, which is placed in the vertical plane and above the horizontal plane. Let us see the next case. In the horizontal plane is the next case. So now this is a point B, which is placed in the horizontal plane and behind the vertical plane. Okay, in the horizontal plane and behind the vertical plane. So now you are here as I am showing you the arrow. So now you can appear the front view on the horizontal plane at the axis point. So here once again you will have the axis point at the same point as A, you will get the B dash point. And where does the top view appears? So look from the top such that it is appeared on the horizontal plane. So it is going to be rotated in clockwise direction for 90 degrees. Okay, and this is going to be appeared above the horizontal plane, and here you put it as point B. Now draw the orthographic projections of the point B, which is placed in the horizontal plane and behind the vertical plane. So now simply draw a line. After drawing a line, simply put a point on the axis, because the point B is on the junction, such that you will put a point B here, B dash here. Just write on B dash because it is a front view, and put a point parallel to this height, so mark it as B dash. So now this is how you can easily identify. Here both the views are on the same axis line and above this one, and both the views are above and on the axis, right? So let us go for the third condition, that is in both the views, right? In both the views or in both the quadrants. So like one horizontal line axis and vertical line, and now you look at this point in both the planes, in both the planes. So this is the vertical plane and this is the horizontal plane. So here if I place this one, this is called as in the vertical plane, and if I place a point here, it is called as in the horizontal plane. Suppose if I place an point here, what it is called? So this is called that the point is placed in both the planes, in both the planes. So now I am placing a point here, that is A. This point A is in both the planes. So once again you are here, you are looking the point A, and where does it appear? In the same place you appear A as well as A dash, front view and top view also. So what will be the projection of the point A, which is placed in both the planes? So now draw the line. So in both the cases, A and as well as A dash is on the midpoint of this vertical plane and horizontal plane. So both the planes also will appear at the same place. So put a point here, mark A dash as well as A. So this is how we satisfy the 9 conditions, and we are not selecting the second quadrant as well as the fourth quadrant, because the views of that projections are going to be overlapped by each other. So that is why both this eliminated, and first quadrant, second quadrant, first and third quadrant are taken into the consideration. So you have to remember very easily by seeing the quadrant system. First of all, you know clearly what is the position of the object. So what is the position of the object? If you know the position of the object, then it is very easy to identify the orthographic projection, how to draw orthographic projection of that particular object. So simple. Above the horizontal plane, in front of vertical, you can say it as first quadrant. Above the horizontal plane, behind the vertical plane, it is second quadrant. Below the horizontal plane, behind the vertical plane, what is third quadrant? In front of vertical plane, below the horizontal plane, it is called as fourth quadrant. So if you go on repeating for a number of times, you will also easily identify the object is placed in the which quadrant. So please go for a number of repetitions. So if you want to get perfection on engineering graphics or drawing, you have to repeat more number of times. Practice. So this is my suggestion, to go for more number of times. It takes a little bit of time, but you also calculate your time when you are drawing first time and you are going for repetition second time and third time, then your time gradually decreases for your solutions, right? So if you go on practice, you will get expertise and you can solve this projection of points within a few minutes. So if I give 4 or 5 number of points, just within a 2 minutes that you are going to solve that problem. So completely watch this video clearly by pausing and by continuing it. Practice simultaneously to this video and get knowledge and get command on the engineering graphics. Thank you. Good luck.